Unit 8 Angle Relationships, Lesson 2 Vertical Angles and Linear Pairs. This should once again actually be something that you have talked about before. We'll probably take it a step farther, put some expressions in it, but you should be familiar with vertical angles. We talked about them back in our triangles unit when we talked about angles that we could say are congruent within our triangles. And then also you should be somewhat familiar from the past with linear pairs. Keep in mind, linear, the name itself has line as the beginning. So you're talking about pairs that are going to create a line. All right, what are vertical angles? Vertical angles are angles that are opposite each other when two lines cross. Vertical angles have to share the same vertex. And vertical angles are always congruent. So here we have a light blue line and a darker blue line. When those two lines intersect, this angle here on the top left and this one here on the bottom right are going to be vertical angles, and they will be congruent or have the same measure as one another. When we look at this diagram, if I wanted to name all of the vertical angles, I'm looking for things that are opposite. So angle 1 is made by this line and this line. So the other angle that's made by this line and this line is angle 4. So 1 and 4. Angle 2 is also made by the same line that we just highlighted a moment ago, and then this line. So also making angle 2 would also create this angle down here, angle 5. And then angle 3, which is made by this line and this one. If I follow those out, it also made angle 6. So 3 and 6 are going to be vertical angles. Remember, vertical angles are congruent. Now, you can also add angles via the angle addition postulate to make pairs of vertical angles, like 1 and 6, those two together. If I were to add them, I would need this line to make that side of the angle and this line to make this side of the angle. And that would be in the 3 and 4 over here would be the angles that were created. So the measure of angle 1 plus the measure of angle 6 is going to be the same as the measure of angle 3 plus the measure of angle 4. So you're just looking at the fact that some of those you could add together. You could do the same thing with 1 and 2. If I added 1 and 2, across from them are 4 and 5, so 4 and 5 would be added up. Now, that's not all of them. Obviously, you could do 2 and 3 with 5 and 6. You can use any combination you want, as long as you're talking about the ones that are across from each other and combining them together. So if you're asked to find the value of x, hopefully this should be pretty easy. It's just right there for you where the angle x is and the 65-degree mark. Those are vertical angles, so that means they have to be the same. So x has to be 65. Now, I didn't include the degrees in my answer because there's already a degree sign on that x variable in the question. Now you can get a little bit more complicated than that. Here you have two expressions, but they're still on vertical angles. This one on the left and this one on the right. There's our x, and they're opposite each other, so they have to be congruent or equal. So x plus 16 has to have the same value as 4x minus 5. Then we're going to collect our like terms. Notice they're on different sides of the equal sign, so you have to do the different of one of them. I chose to subtract the plain old x, leaving me with 16. And then 4x minus x was 3x. Bring down the minus 5. Add 5 to both sides. Divide by 3 on both sides. And we get 7 as the value of x. So x equals 7. You'll notice again, I didn't put a degree sign in there because it's already a part of each of the two expressions that are in the figure or diagram itself. What is a linear pair? A linear pair of angles has to meet two criteria. They have to share a side. In this diagram, the shared side would be MK. And they have to add up to 180 degrees. That's the measure of a straight line. So there's two angles, one here that's marked 104 degrees, and this one that's marked 76 degrees. These two together along the bottom have to make a flat line, a straight line. That's angle JKL, and because it's straight, it has to measure 180 degrees, or half of a circle. So our two linear pair angles are JKM and then LKM, just naming the two sides there. linear pairs have to add to 180 degrees every single time. So here I can see PSR is a straight line, so it's going to be 180 degrees. So PSQ and QSR are going to be our linear pair. They're going to add to 180. So if I wanted to find the measure of angle RSQ, I just need to set up my equation, do my subtraction, and the measure of angle RSQ, one's missing right here, would be 57 degrees. Now, linear pairs and vertical angles can happen together, but they're not the same. So remember, vertical are across from each other. 1 and 3 are vertical, and then 2 and 4 are vertical. Those are not linear pairs. Linear pairs have to share a side. So looking at this diagram, I am looking for things that share a side, but along the bottom make a straight line. So for example, here's a straight line. And to the upper right, I see angle 1. And if I keep going around, I get to angle 2. 1 and 2 together are going to form that nice straight line that diagonals from upper left to bottom right. 1 and 2 would make a linear pair. And 2 and 3, that would make this line that goes from bottom left to upper right. Okay, down here I go down angle 2, keep curving back to angle 3, as well as 3 and 4, as well as 4 and 1. So where you have 2 pairs of vertical angles, you end up with 4 pairs of linear pairs. So if you are asked to find the missing angle measures and you are only given one where 2 lines intersect, we can know them. It's okay. We know every piece of information we need. First of all, I see 131 and E make a vertical angle pair. So they're going to be congruent. So E has to be 131, period. Then I see angle D, or angle F if you want to see it that way, and 131 together make a linear pair. They make this line right here, 131 and D. Or if you're looking at F over here, 131 and F make 180 degrees. So the measure of angle D or the measure of angle F, whichever one you're putting in there, plus 131 has to equal 180. We subtract that 131 and the measure of angle D is 49 degrees. And then angle F is the same because D and F are vertical angles and they have to have exactly the same measure. Let's make that a little bit more complicated. Okay, so I see vertical angles again. You see them? Over here is 63 degrees, and over here I've got y plus 23. So these two are going to make a vertical angle pair. How about solving for x? What could I do there? Well, this angle down here that is marked as 2x minus 17, and this angle that's marked as 63. If I put those two together, they give me this straight line, so they have to add up to 180. So it doesn't matter which one you do first. You just want to look at the angles, see how they relate to one another, and choose one of them to go with first. So I went with vertical angles first because I saw it first. So y plus 23 has to be the measure equal to 63. So we subtract our 23 and we simply get y to be 40. Now the other one had our x in it. The x and the 63, remember those made a linear pair, meaning they add up to 180. So, I don't know what I did there. That is obviously incorrect. Let's fix that. I bet I copied and pasted and wasn't thinking about what I was typing or writing down. So 2x minus 17 plus 63 has to equal 180. So you're going to not subtract or not add your 17, but rather 2x, and then you're going to collect those like terms. So negative 17 plus 63. So really you're subtracting 17. So let's think that through for a minute. If I subtracted 10, it would be 53. And then 53 subtract another 7. So that's going to give me 46. That would be a positive 46, equaling 180. So now we're going to need to subtract 46. And what we do to one side, we need to do to the other. So now we have 2x equals, because the 2x just carries down, the 46 is gone from that side. So 180 minus 46, let's think that one through. 180 minus 40 would be 140. And 140 minus another 6 would be 134. And now we really are going to divide by 2. That step is still the correct solution step because we need to get x alone. X will definitely not be 40 though. X instead will be 134 divided by 2. So let's think that one through. Let's see, 120 or 130. Let's go 130 divided by 2 would be what? Well, 120 divided by 2 is 60. And then it's another 10, so half of that would be another 5. So we're looking at 65. Then half of 4 is 2, so add another 2 to that, and we get 67. So x should be 67 degrees. So I'm sorry about that. I didn't read over my work and make sure I had any typos or anything in it. Obviously, I should have. Okay, so now we're going to have to wait and get all that back on there. Is that our last example? I guess it is. So as you're going through, think about what it is that you have to work with. Am I looking at vertical angles? Am I looking at linear pairs? The difference, vertical angles are congruent. Linear pairs are going to add to 180 degrees. Think through what you have marked and utilize that to help you as you're calculating your answers. As always, if you have any questions, please don't hesitate to let me know.